Okay, on to another problem. AIME, or 2016, AIME 1, question number 5. So we have Anne read a book. On the first day, she read n pages in t minutes, where n and t are positive integers. On the second day, Anne read n plus 1 pages in t plus 1 minutes. Each day thereafter, Anne read one more page than she read on the previous day. And it took her one more minute than on the previous day until she completely read the 374-page book. It took her a total of 319 minutes to read the book. Find n plus t. So the first thing I looked at when I saw this was that each day there's going to be some type of difference. I call that x in the number of pages to number of minutes. So n minus t. And we know that in the total of here, she read 374 pages in 319 minutes, which gives us 55. So all told, there are 55, the difference between the number of pages and number of minutes is 55. And the only factors of 55 are 1, 5, 11, and 55. And so what this means is the following. This means that the first one, either let's see how I want to look at this. It took her 55 days, where n minus t is 1, or it took her 11 days, where n minus t is 5, or it took her 5 days, where n minus t is 11, or it took her 55 days. Sorry, it took her 1 day, where n minus t is 55. Now, in here, it says on the first day and on the second day. That means she does it at least 2 days, so it can't be 1 day. She can't have read the entire book in a single day. And now we look at this. So we know that it took one of these number of days. The number of pages read per day and the number of minutes read per day form both arithmetic sequences, where we have sort of, let's call it, so n sub I, sure, equals n plus d minus 1. I guess I can change this to n sub d for that day. So when d is 1 on the first day, 1 minus 1 is 0, we just end up with n. We know that the number of minutes, t sub d for that day, is going to be that starting value of t plus d minus 1. And because of the way that arithmetic sequences work, the average of all the days is going to be equal to this sort of middle number. They're all odd, so they all have a middle day. The third day is in the middle of 5 days. The sixth day is in the middle of 11 days. That's going to be 28th day is in the middle of 55 days. So the only way to make this work, because I say that it's like whole pages and whole minutes, not parts of pages and parts of minutes, is that these need to divide by one of these. Well, clearly 5 does not divide 374 or 319. So it can't be 5 days. Neither does 55. And so I look at this, well, maybe 11 does. And when I go through and do the work, so 374 divided by 11 gives me, so that's 33 minus that, we get 44. I get 34. 319 divided by 11. Well, that goes into that 2 times, 22, subtract, and that gives me 29. So 11 is the only case that works. On the 6th day, n sub 6 is going to be 34, and t sub 6 is going to be 29. And either I can sort of use this arithmetic sequence formula, or I can just count back. If I need to get to 1 from 6, I need to go back 5. So this would give me n equals 29. And same thing here. If I want to get back to t1 from day 6, I'll go back 5 spaces. So t is 24. And finally, I can do 29 plus 24, and that will be 53, with the 0 in there because we need to bubble in 3 digits. Comment with any questions. There is more than one way to do this. I could have done more with the sum of an arithmetic sequence formula, but this way I thought was a really nifty way to get it without having to do too many calculations.